Hello, we're Group 11 and today we are here to talk about CFD simulation of a blender using Star CCM+. This presentation has the following topics: introduction and motivation, materials and methods, results and discussion, conclusions, and finally, future work mixing. The primary aim of the mixing is to improve the interfacial mass transfer rate in the vessels, which is related to interfacial area between faces, volume fraction hold-up, bubble droplet, or particle size distribution. This is why the characterization of the phenomena during agitation is an important file to study because it can improve the quality of the products or can prevent damage of the reagents. In general, to obtain the power curve and for the modeling of the gas-liquid interface, it was necessary to develop a 3D CAD model using Autodesk Inventor that described and represented the blender selected for the study. After this, the geometry was imported into Star CCM+. Then, the rotating solid, corresponding to a solid surrounding the blades of the blender, was separated. Finally, the interfaces were generated and the internal volume was extracted. Following, the measure specifications are presented. Here we can see the characteristics and the values for the measures, for the default control, and the physics models specifications. In addition, for the third part of the project, a simulation was run taking into account phases inside the blender. This reproduction was simulated with the minimum velocity of the blender and considering the volume fraction of liquid and gas. And, due to the fluid was water, it was assumed turbulent flow to model this property with K omega and SST models. Now, these are the results of the final mesh in Star CCM+, which has around 330,000 cells. In addition, here we can see a scalar scene of the velocity magnitude of the blender created in Star while a simulation started to run. As it can be seen, there is an inversely proportional relationship between the power number and the Reynolds number. Also, it can be observed that during the laminar regime, the power number presents a negative linear slope and the turbulent regime has almost constant power number around it. Now, it can be seen how the vortex of the blender remains constant when the velocity magnitude increases. When the speed is high and exceeds a certain critical value, the movement of layers is very regular, so it will form a circular currents called vortices, which increase resistance to the fluid displacement. These irregular speed components are transverse to the direction of the flow, and the velocity will not remain constant for the same point. Now, these are videos taken from the experimental procedure of the liquid-gas interface. As a conclusion, the impeller blade number is not a significant factor that affects power number, so it's important to take into account the baffling for future studies because the power number for most impellers remains constant in the buffet configuration, while it decreases with an unbuffet configuration.